My dear students, welcome back. I hope you and everything is fine and safe around you. Please stay at home, save yourself, family, and society. Coming to the database management systems course. In today's session, we will discuss about the normal forms. Okay, in the previous sessions, we have discussed about the functional dependencies, multi-valued dependencies, fully functional dependencies, and partial functional dependencies. So, in the normal forms, actually, our aim is with the help of normal forms, here we will reduce the redundancy in the relational model. Okay, so here first we will see what is the use of normal forms, why we are using the normal forms, what are the different types of normal forms. After that, we will move to one by one normal forms. Okay, so normalization, wherever you will listen this word, definitely please simply say that normalization is the process of organizing the data. It is used for to reduce the redundancy. Okay, that's enough. Okay, so not only in the database management system course, you will consider any course. Okay, wherever you will listen the word normalization, then simply say that it is used for to reduce the redundancy. Okay, so actually one of the main advantage of database management system is to organize the data. Okay, so in this point of view, organizing the data point of view, here we have several, actually the data is available in several formats. Okay, structured data, unstructured data, semi-structured data. So organizing the data is very important, because of the data is available in particular format, then only we will observe all the things. Okay, otherwise we can't understand the data. Okay, so actually why we are using the normalization? To reduce the redundancy. Okay, where we will reduce the redundancy? Here in the database management systems course point of view, here we will consider relational tables. Okay, so already at the time of data models, we are covered a lot of data models: hierarchical data model, network data model, entity relationship model, object oriented model. Okay, so in all these data models, most of the users, most of the programmers using only the relational data model. Okay, so the relational data model is available in the form of tables. Okay, so definitely the illiterators also observed the data with the help of tables. Okay, so here why we are using the normal forms? Another usage is it eliminate the undesirable characters. What is the meaning of undesirable characteristics here? Okay, so eliminate the undesirable characteristics like insertion anomalies, updation anomalies, deletion anomalies. What is the meaning of anomalies, my dear students? So here the anomalies means problems that can occur in poorly planned, unnormalized databases where all the data is stored in one table. Okay, so definitely it causes the redundancy, undesirable characteristics. Now our aim is to reduce the redundancy. Okay, so in the next slide, I will mention what is the meaning of insertion anomalies, updation anomalies, deletion anomalies. Okay, so okay, next, actually, with the help of normalization, we will divide the larger table into the smaller table. That facility is also available here. Okay, so here we will divide the larger table into smaller table, but here we can't misuse any data. We can't lose any data. Okay, definitely here we will provide the link them using any one of the relationship, no problem. Okay, so that facility is also available in the normalization. Okay, so simply finally most of the others say that why we are using the normalization means it is used to reduce the redundancy. Now we will see what is the meaning of redundancy. Okay, if suppose the redundancy is there in our table, what are the problems we will face? Okay, so now let us see the problems caused by the redundancy. Okay, so suppose the redundancy is there in our relational table, then we will face the problems. What are the problems caused by the redundancy? Mainly here, three problems: insertion anomalies, updation anomalies, deletion anomalies. Now we will see one by one. So before we will move to the anomalies, first we will see another problem caused by the redundancy is redundant storage. Okay, actually suppose we will consider the college database. In your college, definitely more than 5,000 students are available. Okay, in those 5,000, 2,000 are students are related to the CSC, 2,000 related to the EC, 500 related to the mechanical, 500 related to the civil engineering. Okay, so now we will see what is the meaning of redundant. Okay, so some information is stored repeatedly. Okay, here actually 2,000 students, CSC students are available. So for each and every student, we will mention the branch column. Okay, definitely we will mention the branch column. So for each and every, for all the 2,000 students, definitely we will mention this student is related to CSC, CSC, CSC. Definitely we will fill CSC name 2,000 times because here 2,000 students are available. That's why definitely we will mention for all the students, definitely CSC, branch name is CSC, definitely filled. Okay, that is the meaning of redundancy. Now we will see how we will reduce the redundancy. Okay, so first we will discuss what is the meanings of updation anomalies, insertion anomalies, and deletion anomalies. After that, we will move to the brief explanation about these things. Okay, so updation. What is the meaning of updation? One copy of such repeated data is updated and inconsistency is created unless all copies are similarly updated. Okay, now we will see what is the meaning of updation anomalies, what is the meaning of insertion anomalies, what is the meaning of deletion anomalies. So here I will mention the link also. Okay, with the help of this link, now we will see what is the meaning of these are three anomalies. Okay, so my dear students, please listen carefully and please observe carefully because these problems are caused by the redundancy. Okay, if you clearly understand about this then only you will understand about the normal forms. Okay, now my dear students, please listen carefully. My dear friends, welcome to my channel. Myself, Gaur Bharat Kumar, working as assistant professor in the department of CSC. In today's session, we will discuss about normalization in DBMS. Okay, actually, what is the meaning of normalization? Why we are using the normalization? Because the redundancy. Okay, so here with the help of normalization, here we will reduce the redundancy. That is our main agenda here. So in that point of view, here I will consider one small information here. So now with the help of this information, now I will explain what is the meaning of normalization, how we will reduce the normalization, what are the problems caused by the redundancy, actually why we will apply the redundancy here. Okay, why we will reduce the redundancy here, because here we will face some problems. So that's why here our main agenda is to reduce the redundancy. So in this actually in this example, I will consider 8 students information here. Okay, so here we will consider some student table information. In this particular fields are student ID, student name, credits, department name, building, room number, like that. Okay, first actually what are the problems caused by the redundancy? Here we have 3 different problems we will face: insertion anomalies, updation anomalies, deletion anomalies, like that. Okay, so actually what is the meaning of anomaly here? Simply the anomaly means data is having multiple copies. Okay, suppose in our table we have multiple information is available, then that is regarding to the anomaly. Same, the redundancy is also we will consider more than. Bhavani, is it audible? We will consider the information more times. Okay, so now our aim is to reduce the redundancy. Okay, in this particular example, what is the anomaly or what is the duplicate? What is the Venkatalakshmi? Is it audible? Copies here. Suppose we will consider the department name. So actually, the student ID 1, student name Raja is related to the CSC department. So here, what is the building name here? B1, room number 102. So for every time, okay, suppose the student is related to the department CSC, definitely we will consider the building name as building name and room number as B1 101. Okay, please observe the second student ID information also. Suppose we will consider the eighth information is also related to CSC department student. So another information B1 and the room number also 101. So in these times, okay, actually here we will mention the department name 3 times here. Okay, so student ID 1 to 8 are related to the CSC department. Definitely he will stay at the B1 room, and the room number is also 101, same. Okay, so but why in these how in these times, that means a lot of times we will represent here, so that is caused the redundancy problem. Okay, now we will see how to rectify this type of problems. Okay, so here, what is the meaning of insertion anomalies here? Actually, the problems caused by redundancy is insertion anomalies, updation anomalies, deletion anomalies. First, we will see what is the meaning of insertion anomalies. Suppose here we will consider another information. Actually, here up to now CSC, CEEE, civil information is available, but until now the mechanical information is not available here. So now my aim is to consider another information here. So mechanical building is 3 like 205, like that. Okay, but no students are present here, so that's why definitely it is replaced by null values. Okay, because here actually here we will discuss about the insertion anomalies. That's why here I inserted another information data, but here no students are related to the mechanical department. That's why here I am represented this information with the help of null. But here student ID is related to the primary key, but the primary key null is not accepted here. Okay, so this type of problems are related to the insertion anomalies. Okay, suppose another example is, suppose my aim is to insert another information, student ID 9. So Kumar, sub percentage 8. Okay, so he is related to the CSC department. Suppose by mistake, by typing problem, here I will mention the B2 black. Actually, what is the CSC building? B1. Okay, so here by mistake I will type the B2. Okay, actually this type of problems are related to the insertion anomalies. Are you understand my point? Okay, actually this type of problems are related to the insertion anomalies. Okay, now we will move to the updation anomalies. What is the meaning of updation anomalies? Suppose by any problems, we will shift the building, CSC building is moved to the B3. Okay, suppose in that situation, actually until now the CSC is stay at the B1 building. So due to some problems, we will shift the building to the B3. At that time, we will update all the information who are available in the CSC department here. We will update all the information. Okay, in this this is the meaning of updation here. Okay, at this time definitely we will update all the information of our building as well as number, because here the room number is also depending on the building is depending on the department name, okay, that's why here also we will update the all the student building and room number also. Okay, this is the this is the problem related to the updation anomalies. Suppose here will be another example. Suppose we will consider another field here, HOD name. Okay, HOD name or another information, HOD phone number, like that. Okay, HOD phone number. Definitely here each and every, suppose the student is related to the CSC department, Then here HOD name and HOD phone number are related to all these students are same. Okay, so because these students are related to the CSC, so that's why HOD phone number, HOD name also same for all the CSC department students. All the Triple G department students, HOD phone number, HOD name also same. All the civil student HOD phone number, HOD name also same. Okay, but in these type of situations, suppose here we will consider only 8 or 9 fields of information, but we have lot of information is available, more than 100,000 like that. Okay, at that time definitely we will face some problems. That's why here our solution is to reduce the redundancy. Okay, so this is the information about updation anomalies. Now we will discuss what is the meaning of deletion anomalies. Suppose one student is not promoted to the next semester. Okay, so in that time definitely we will delete. The good manner is to delete those details. Suppose the student ID 4 is not promoted. In that situation, definitely we will delete all these. Okay, we will delete all these information, but that is not a good manner, because here the department name, building, room number, HOD phone number, HOD name, these all the fields of information is available. But here the now not promoted student is only student ID 4. Okay, so here the remaining information is also deleted. That's why that is related to the deletion anomalies. Okay, so this is the problems. These are the problems caused by the redundancy. Now we will find out the solution. How we will find out the solution for these problems? Here the problems are insertion anomalies, updation anomalies, deletion anomalies. Now we will find out the solution. Here the solution is to rectify these problems with the help of redundancy. So now we will decompose. Okay, here 8 field, suppose 6 fields of information is available here. Now we will decompose these information. Okay, so here I will consider. So decomposition means the whole table is okay. Actually, in the above table we have lot of information. With the help of above table, now we will divide those information into 2 tables, some smaller tables. Okay, so please observe here. Here also all the information is available. Okay, we will not delete any information. Okay, so suppose we will consider the department table. All the department numbers, okay, block numbers, room numbers are available. Whatever information is available in the top table, all the information is available in the department table. Here we will not delete any information. Okay, please observe here. Okay, so but we here for the point of view, here our aim is to find out the solution. In this point of view, here we will decompose the table into the 2 tables. Okay, so that's why here I will consider all the department names. Okay, here we will not repeat that. Okay, only one time we will consider. Okay, CSC, ECE, Triple G, Civic. Okay, so here we will consider the building names and the room numbers are also. Okay, so this is the department table. Now we will consider another table, that is the student table. Okay, all the student details are available here. Okay, 8 student, Raja, Rama, Sita, like that. Okay, credits are available. Department name is available here. Okay, so here please observe for these 2 tables. Okay, student table and department table, here some relation is there. Okay, so actually what is the primary key available in the department table? Department name is the primary key, because here building number and room number are depending on the department name. Okay, so here department number name maintains the unique field of information. That's why this maintains the primary key. Here we have a facility, referential integrity constraint. Okay, in this type of problems we will face some referential integrity constraints. If you want any information regarding to the referential integrity constraints, please go to my previous video. Okay, so here we will mention one foreign key here. Okay, so what is the meaning of foreign key? Okay, the foreign key is already available in the another table with the primary key. Okay, so that's why in the students table, department name is the foreign key. Okay, so this department name is related to the department table department name. Okay, so this is the relation between student table and the department table. Okay, now we will see the already the problems caused by the redundancy. Suppose our aim is insertion anomalies. Okay, so what is the insertion anomalies? Suppose at that time we will insert any mechanical department name. So simply here, please enter the mechanical department, some building, okay, 120 room number, like that. Okay, no problem. But in the previous, we will consider the department name, building name, and room number, but we don't have any students. Okay, the students are not present in the mechanical department. Okay, that is the problem. Okay, if you want any information here, please consider in this table. Okay, no problem. So at this time we will not mention any student details. Here no mechanical students are available. That's why here we will not consider any mechanical student details in the student table. Okay, so that is the, here we will rectify the insertion anomalies, updation anomalies. At the time what we will discuss, suppose the buildings are changed. Okay, actually the CSC is B1. So at some problems, due to some problems, the building is shifted to the B3. Now please mention simply the B3. Okay, this is very good manner. Simply we will replace only one value. The help of one value, all the information is automatically changed. Okay, so that's why here we will rectify the updation anomalies also. Suppose we will consider the deletion anomalies. What is the meaning of deletion anomalies? So by mistake, student ID not promoted to the another semester. That's why here at that time we will delete all the information of student ID. Student name, credits, department name, building, room number, all the information we will delete it. But at this time, simply we will delete student ID Rama, credits, department name. Okay, another department EEE also available with the student ID 3. Okay, now we will delete simply the student details of student ID only. Okay, this is the information about problems caused by redundancy, how we will rectify those problems. Okay, if you have any doubts, please ask me in the public chat. I will explain. Okay, so thank you very much for watching. Thank you. Now we will see the different types of normal forms. Here we have 6 different types of normal forms are available in the database management system. First normal form, second normal form, third normal form, next BCNF, boys code normal form, fourth normal form, fifth normal form. Okay, so my dear students, please remember in this order only. Okay, so you can please observe that after the third normal form we have BCNF is available. Okay, then only fourth normal form and fifth normal form is came. Okay, so why we will remember in this order only? Because suppose we will convert the table into the second normal form. Okay, suppose here our aim is we will consider one table. Please convert the table of information into the second normal form. That is our question. Now first our answer is, first we will convert that information into the first normal form. Okay, my dear students, so ఎప్పుడైతే హైయర్ నార్మల్ ఫామ్ లోకి కన్వర్ట్ చేస్తున్నాము, ఓకే, ఫస్ట్ దానికి ముందున్న నార్మల్ ఫామ్ లోకి కన్వర్ట్ చేయాలన్నా, దెన్ ఓన్లీ we will convert into that particular normal form. Now our aim is to convert the table of information into second normal form. Okay, so first మనం అబ్జర్వ్ చేయాల్సింది ఆ టేబుల్ అనేది ఫస్ట్ నార్మల్ ఫామ్ లో ఉందో లేదో అబ్జర్వ్ చేయాలి. ఫస్ట్ నార్మల్ ఫామ్ లో లేకపోతే ఫస్ట్ మనం ఫస్ట్ నార్మల్ ఫామ్ లోకి కన్వర్ట్ చేయాలి. ఆ తర్వాత సెకండ్ నార్మల్ ఫామ్ లోకి కన్వర్ట్ చేయడానికి మనకి కొన్ని టర్మ్స్ అండ్ కండిషన్స్ ఉంటాయి. వాటిని బేస్ చేసుకుని సెకండ్ నార్మల్ ఫామ్ లోకి కన్వర్ట్ చేస్తాం. సపోజ్ నాన్న మై ఎయిమ్ ఇస్ టు కన్వర్ట్ ద గివెన్ రిలేషనల్ టేబుల్ ఇంటూ ద ఫోర్త్ నార్మల్ ఫామ్. ఓకే, సో ఏదో ఒక టేబుల్ ఇచ్చాడు, ఫోర్త్ నార్మల్ ఫామ్ లోకి కన్వర్ట్ చేయమంటే ఫస్ట్ మై డియర్ స్టూడెంట్స్ ప్లీజ్ రిమెంబర్, సో ఫోర్త్ నార్మల్ ఫామ్ కి ముందున్న నార్మల్ ఫామ్ ఏంటి నాన్న? ఫోర్త్ నార్మల్ ఫామ్ కి ముందున్న నార్మల్ ఫామ్ ఏంటి? ప్లీజ్ రెస్పాండ్ మై డియర్. BCNF. సో ఫస్ట్ మీరు ఏం అబ్జర్వ్ చేయాలంటే ఆ పర్టికులర్ టేబుల్ అనేది BCNF లో ఉందో లేదో చెక్ చేసుకోవాలి. ఓకేనా? BCNF లో ఉంటే మాత్రమే మళ్ళీ ఫోర్త్ నార్మల్ ఫామ్ కి కొన్ని టర్మ్స్ అండ్ కండిషన్స్ ఉంటాయి. విత్ ద హెల్ప్ ఆఫ్ దోస్ టర్మ్స్ అండ్ కండిషన్స్ వి విల్ కన్వర్ట్ దట్ ఇన్ టు ద ఫోర్త్ నార్మల్ ఫామ్. ఒకవేళ BCNF లో లేదనుకోండి, ఫస్ట్ మనం BCNF లోకి కన్వర్ట్ చేయాలి. దెన్ ఓన్లీ వి విల్ కన్వర్ట్ దట్ టేబుల్ ఇన్ టు ద ఫోర్త్ నార్మల్ ఫామ్. మై డియర్ స్టూడెంట్స్, ఐ హోప్ ఆల్ ఆఫ్ యూ అండర్స్టాండ్ మై పాయింట్. ఎనీ డౌట్స్? అర్థమైంది నేను చెప్పిన పాయింట్. సపోజ్ ఫిఫ్త్ నార్మల్ ఫామ్ కన్వర్ట్ చేయాలంటే ఫస్ట్ అది ఫోర్త్ నార్మల్ ఫామ్ లో ఉందో లేదో చెక్ చేసుకోవాలి. ఒకవేళ లేకపోతే ఫోర్త్ నార్మల్ ఫామ్ లోకి కన్వర్ట్ చేసుకుని తర్వాత మనం ఫిఫ్త్ నార్మల్ ఫామ్ లోకి కన్వర్ట్ చేసుకోవాలి. ఓకే, సో దీస్ ఆర్ ద డిఫరెంట్ టైప్స్ ఆఫ్ నార్మల్ ఫామ్స్. నౌ వి విల్ సీ ద డెఫినిషన్స్. Okay, so definitions of all the normal forms, Nana. So for the examination point of view, the definitions and examples are enough, Nana. Okay, so what is the meaning of first normal form, my dear students? So here, please observe, please note down these definitions. So a relation is in first normal form if it contains an atomic value. Okay, so definitely in each and every cell it maintains the atomic values only, then only the table is available in the first normal form. Okay, so what is the meaning of atomic? Okay, those things we will discuss at the time of discussions of first normal form, no problem. Just please remember these points up to now. Okay, so what is the meaning of second normal form? So please observe that a relation will be in second normal form if it is in 1NF. Okay, definitely my dear students, second normal form lo undani cheppali ante the table already is available in the first normal form. Okay na, so first normal form undali, tarvata matrame next condition cheppadu chudandi anna. So what is the condition for second normal form? All non-key attributes are fully functional dependent on the primary key. Okay, so what is the meaning of fully functional dependent, my dear students? What is the meaning of fully functional dependent? In the last class already we have discussed about the fully functional dependent, partial functional dependent. Please respond, my dear students.
100%.
Definitely. Okay, very good. Okay, so suppose we will consider LHS implies RHS. RHS 100% dependent on only that LHS does not. Okay, LHS here the RHS does not dependent on the subset of, here the RHS does not dependent on the subsets of LHS. Okay, that is the meaning of fully functional dependent. Okay, at the time of second normal form definitely we will observe that. Okay, either all the attributes are presented in the fully functional dependent or not. Okay, so fully functional dependent untene that is the second normal form. Now what is the meaning of third normal form? So a relation will be in third normal form if definitely that is available in the second normal form, then only we will convert into the third normal form. Here my dear students, please observe here, in the third normal form does not allow the transition dependency. Okay, so transition dependency, what is the meaning of transition dependency? What is the meaning of transition dependency, my dear students? Actually the transition dependency is one of the property of functional dependency. What is the meaning of transitivity annam kada, transitivity dependency? I think that is the third property of functional dependency. What is the meaning of transitivity? If X implies Y, Y implies Z, then if X implies Y, comma Y implies Z, then simply we will written as
X implies Z.
X implies Z, that is correct. Okay, so here no transition dependency, that means the transition dependency is not allowed in the third normal form. ఒకవేళ ట్రాన్సిషన్ డిపెండెన్సీ ఏమైనా ఉంటే వాటిని రిమూవ్ చేయాలి. ఓకే, నెక్స్ట్ BCNF. Actually the BCNF is the advanced version of third normal form. So in some situations the BCNF is also called as the 3.5 normal form. So it is the extension version of third normal form, that's why it is stricter than third normal form. Here what the BCNF condition, please observe here, here we will consider the functional dependency x implies by x is a super key of the table. That means definitely we will consider the functional dependencies here. Okay, so here the LHS is always the super key. My dear students, are you know about the super key? Are you know how to find out the super keys? Please
Yes, sir.
respond. Okay, so I will share the YouTube link, no problem. Once please go through that YouTube link, how to find out the candidate keys, how to find out the super keys, what is the meaning of prime attributes. Actually, in the second normal form, we want the non-prime attributes. Okay, so how to find out the prime attributes here, non-key attributes means non-prime attributes. Okay, those things I will share the YouTube link, no problem. Okay, so here x is the super key of the table. Okay, so already తెలుసు అంటున్నారు కాబట్టి no problem. Now the fourth normal form. Suppose here our aim is to convert the given relational table into the fourth normal form, then definitely it satisfies the Boy's code normal form and has no multi-value dependency. Okay, that means the fourth normal form does not allow the multi-value dependency. My dear students, what is the meaning of multi-value dependency? What are the conditions in the multi-value dependencies? In the last class, that means in the yesterday class, we are discussed about that multi-valued dependency. Multi-valued dependency means how we will say that the multi-valued dependency is there in the table or not. Definitely it is possible with 3 fields. Okay, so particular table లో 3 fields 3 columns ఉంటే మాత్రమే మనం మల్టీ వాల్యూ డిపెండెన్సీ సాటిస్ఫై అవుతుందో లేదో చెప్తాము. ఇన్ దీస్ 3, 2 are the independent, these 2 are dependent on the third attribute. Are you remember those points, my dear students? Multi value dependency, here we will maintain 3 fields of information. In those 3 fields, 2 fields are independent and these 2 independent are dependent on the third field. Okay, so the fourth normal form does not allow the multi-value dependency. Coming to the fifth normal form, definitely it satisfies the fourth normal form and does not contains any joint dependencies. Okay, so these are the rules of all the normal forms. Okay, finally we will conclude that the first normal form means only the atomic values are accepted. Second normal forms means it accepts only the fully functional dependent. Third normal form does not allow the transition dependencies. BCNF, we will consider the functional dependency, the left hand side always the super key. Fourth normal form does not allow the multi-value dependency. Fifth normal form does not accepts the joint dependency. This is the information about all the normal forms. My dear students, if you have any doubts, please ask me. My dear students, if you have any doubts, please ask.